Now, in this age of fake news, you need to be more critical and always look for details before making a judgment, right? Always look at stuff. Now, what do you look for? A lot of things. But guess what? Even in math, some fake or bootleg or imposters, there are some, yet, and numbers may look like scientific notation, but actually they are not scientific notation. So how will I know? Okay, how will I know? That's our lesson for today. Adjusting factors to make them scientific notation. I just won 3.6 million in the lottery. Do you realize you just use scientific notation? See, that number in itself is scientific notation. You mentioned you mentioned the following. What did I mention? Check it out. You mentioned 3.6. That's a number between 1 to 10. You mentioned million. That's a base 10 number. Now, but not all numbers are written in scientific notation. Let's look at this. Now, we will learn two methods because some of the numbers you see are not really scientific notation. The first method is expand the factors, multiply the factors, then convert to scientific notation. It's kind of longer than the other, but let's go over it. All right, so for our first example, look at this. It may look like scientific notation, right? If you look at the numbers, it may look like scientific notation, but check this out. Check this out. It isn't scientific notation because if you look at this number, okay, let me write first. If you look at this number, it's not a number between 1 to 10. So the expanded way is to write it down as usual, 32.2. 10 to the fifth has a value of what? It has a value of 100,000. Okay, next, when you multiply this, how do you multiply it? You could do it the long way, or you could just add zeros to the right, but don't just add all of these 5 zeros. You only add 4 zeros, right? So you know that. And our answer will be 3,220,000. Okay, next. So this is not in scientific notation. The next step is to make it, it's a standard form. Now let's make it scientific notation. So how do we do that again? A number between 1 to 10. This becomes what? And then that becomes 3.22 times a power of 10. 10 to what power? 6. So we know that already. Okay. Next, we now move on to the second example. Okay, so for this example, if you look at this, it may look like scientific notation, but it isn't. It's a bootleg one. Why? Because it's 123. You know that, right? So the first thing we have to do is to simply multiply them. Expand them first. So that's 123.92 multiplied by 10 million. Okay, do your own way, long way, or add zeros, whatever is easy for you. You will get this number 1,239,200,000. But this is in what? It is written in standard form. Now we convert it into the real scientific notation. How do we do that? Again, look at this. We need a number between 1 to 10. We will put the decimal place there. We know that. That becomes what? 1.2392. Now multiply it by 10 to the ninth power. If you're not sure why it's 9, look at this. 3, 6, 9. There you go. Now it's scientific notation. Now let's try another example. Okay, now we're multiplying by a negative exponent in the base 10. So again, look at this number. Let's just multiply the number, expand it first. Same number times 0.00001. Okay, use any method you want. That's going to be a small number, right? But what's the exact value? Again, we need to make a number between 1 to 10 here. So that's going to be 3.27 times 10 to the negative 8. Are you sure it's negative 8? Let's count 1, 2, 3, 4, 5, 6, 7, 8. Yeah, -8. Now think of a shortcut. Actually, that's what we want to know. If I make adjustments here to make it a number between 1 to 10, I should also make adjustments here. How do I do that? Think of a way. Think of a process. We will talk about that in the second method. Next, try this on your own. So again, expand to multiply, and then simply multiply. Now it's in standard form. Now you can adjust. That becomes 9.07. Where did that come from? From there. Since it's a smaller number, the decimal moved to the left. So that's going to be times 10 to the not 7, but -7. All right, -7. 1, let's count. 1, 2, 3, 4, 5, 6, 7. So there should be a -7 here. All right, so that's our answer. Again, think of a shortcut. Now we talk of the shortcut. This is called the Lars method. Think of Lars, left add, right subtract. It's simply, it follows a concept of balancing things. If you add something, okay, on the left side, you should compensate on the other side. If you subtract something, you should compensate on the other side. Okay, so how shall we do that? Let's move on. So think of LA as left add. Remember the Lars? Okay. Moving decimal point to the left makes the number smaller, right? Move the decimal point to the left makes it smaller. And then to balance it out, on the other side, add zeros. Remember that. Now look at this example. And then we'll look at the example later. Now, moving the decimal point to the right makes the number bigger. To the right makes it bigger. Okay, to the right makes it bigger. Okay, therefore you have to subtract zeros. Subtracting zeros or decimal spaces to the power of 10, making it smaller. Okay, that's to balance things out. You will understand it better with this example. Let's start with this. So this is not a number between 1 to 10. So what do I do? The decimal point should be here, right? Okay, if it has to be there, I will have to adjust. What did I do? I moved it 1, 2. So what did I do? I made it smaller, right? Making it smaller. I move to the right, If I move to the right, Lars S. So I need to subtract. What do I need to subtract? From the exponent. So 12 minus, I need to subtract, since I moved 2, I need to subtract -2 here. So that's why the exponent is now 10. Okay, again, Lars, I move to the right, S, subtract -2. Okay, let's try another example. So I move to make it 2.2. The decimal point needs to be here, remember? So I move 1, 2, 3. There's a third one here. I don't know what happened to the animation. There's a third one there. So therefore, Lars S subtract. So I put a -3 on that side. Keep change opposite. -12 minus 3 is a -15. So everything is adjusted now. 2.34 times 10 to the -15. All right. From a fake scientific notation, it becomes authentic, a real one. Okay, next example. Now, let's adjust this again. Do it on your own. Oh no, this is another one. So, a while ago, we now move to the left one here to make it 1.26. Okay, L-A. So, the next one now is La. Left, therefore add. How many will I add? 1. Because I moved only one space to the left. So I added 1 on the exponent. Therefore, that's now a 1.26. You're not a 9 anymore. You will be a times 10 to the 10th. Now here, I want the decimal point here. All right. So again, I move to the left. How many times? 2 times. Therefore, let's make adjustment. 1, 2. So left 2, L, A. Add. I need to add 2 on the other side. Okay, I make it, I add here. So negative 9 plus 2 is a negative 7. Write it as an exponent. So 1.206 times 10 to the negative 7. Okay, got it? Okay, practice. At this point, pause the video, copy and answer the question, and then play the video again so you can check your answer. Ready? Here we go. Pause. Answer. Ready? Okay, so move 1, 2, 1 point. You will move to the left, therefore add 2, therefore 1.70876 times 10 to the 47. Remember, LA. Now, again, I move to the left. I want the decimal point. Oh, no, I don't move to the left now. I move to the right. Lars subtract. So I'll do subtracting how many? 1, 2, 3, 4. Therefore, I will write, I move to the right. Yes, it partners with an S. Subtract minus 4. So negative 7 minus 4 is negative 21. So this is my first factor. This is my power of 10 to the negative 21. Good job. Next, try this again. Pause. Ready for the answer? Here we go. Make adjustments. You want the decimal point to be here. Okay. So from here, I will have to move to the left. La, L, and A. All right. A. I'll be adding something there. But how many? Check. 1, 2, 3, 4. 4. Therefore, L, A, I add 4 to the exponent. Add 4 to the exponent becomes 27. So we're done. That becomes 2.3984 times 10 to the 27. Good job. Okay, let's see your next problem. Okay, the decimal point is over here, but ideally scientific notation should be here. So I move to the right. LAR, R, and S. So I'll subtract something. How many? 1, 2, 3, 4, 5. So I will subtract 5 on the exponent. Negative 13 minus 5 is negative 18. Write your first factor, 2.34 times 10 to the negative 18. Did you get it right? Okay, good job. Now, if you got it wrong, feel free to play the video again from the start. Good job. And we stop.